Welcome to my math class. I am Mohammed Ali, online maths teacher. Today we try to solve one question from Cambridge IGCSE Mathematics Paper 4 Extended 0580 Variant 43 May-June 2023 Question number 6. Question number 6. The cumulative frequency table shows information about the speed of each of 200 cars as they pass a speed camera. Speed, a velocity, a kilometer per hour, velocity less than equals to 70, cumulative frequency is 12, velocity less than 80, cumulative frequency 46 is given. So on the grid, draw the cumulative frequency diagram. So one thing we know that cumulative frequency we have to show in the vertically and horizontally we have to show the speed and the coordinate where the coordinate is put, it is always put the last value, that means velocity less than equals to 70. Here we indicate the 12. Okay. Now uh, this cumulative frequency curve for this diagram vertically 2 centimeter we have taken here, it's already taken 2 centimeter as a 20. So as 2 centimeter 20, that means for each box vertically each box, that is one box equals to 20 divided by 10, that means 2. We will count each box as a 2 vertically. And horizontally, horizontally it is 2 centimeters as a 10. That means one box equals to 10 divided by 10 equals to 1. One box will count as a 1. Horizontally, one box will count as a 1, and vertically, one box will count as a 2. It is very important information for us. Now, if we want to draw the cumulative frequency curve, at first, cumulative frequency 12, velocity less than equals to 70. So, velocity less than equals to 70. Here is 70 and it is 12. Why 12? This is 2, 4, 6, 8, 10, 12. So this is one coordinate. The second one, less than equals to 80, 46, cumulative frequency 46. Here it is 80, cumulative frequency 46. This is 42, 44, 46. Here is the 46. And 80, this is 46, another coordinate. Now, V less than equals to 90, 115. 90. 90 is here, 115. So, this is 120. So, 120, this is 118, 116. So, obviously, 115 is here. This is another coordinate. Now, V less than equals to 95, 155. 95, where is 95? 95 is here. This is 95 and 115. 115. This is 95. 115. This is 60. 160. 106. 58. 156. So 155 is here. Okay. Now V less than equals to 100. 177. 100. At first 100. This is 100. This one is 100. 177. So this is 100. This is 100. That means 177 means 178. 177 is here, this point. And finally, V less than equals to 120, 200. Cumulative frequency 200. So cumulative frequency 200 here, and this is 120. In 120, this is V less than equals to 120. This is 200. So all these coordinates we get. Now here already I have drawn here. So you can join smoothly. So smoothly if you join, this is one coordinate joint, another coordinate, smoothly join here. Okay. Now smoothly join. So our cumulative frequency diagram drawn. Okay. So Roman 1 completed. Now Roman 2, use your cumulative frequency diagram to find an estimate of the median. One thing you have to remember, for median we have to use the formula n divided by 2. So n is what here? 200 divided by 2. That means 100 position will be the median. 100 position. Where is the 100 position here? Here 100 position is here. So 100 position corresponding speed is, this is 1, 2. That means if it is 90, that means 88, 86, okay, 90, this is 89, 88, 87.5. This point is 87.5 because horizontal will take one box 1 centimeter. As it is 90, let me check. It is 90. So 90, that means it is 89, 88. So this is 87. So it is 87.5. So median is 87.5 kilometer per hour. One thing, this is the position. This position we have to put here. This means 100 position and corresponding kilometer. So as it is intersect over there, as it is 90, that is 89, 88, that one is 87. So this is between 87 and 88. So it is 87.5. Median is 87.5. So interquartile range. If we want to find out interquartile range means the difference between upper quartile minus lower quartile. Upper quartile is Q3. Q3 means what? 3n by 4, and lower quartile is n by 4. So 3n by 4. N is 200. So this is 3. N is 200 here, divided by 4. So this is, if you cancel 50, that means 100. 50th position will be the upper quartile. And 200 divided by 4, that means 50th position will be lower quartile. So 115th position from the graph, 150th position. This is 100. This is 150th position. Corresponding value here. Corresponding value, this is 94. Why 94? This is 100, 99, 98, 97, 96, 95, 94. So upper quartile, that means Q3 is 94. Q3 is, so Q3 is here 94. We have to write here 94. So this is 94 upper quartile, and lower quartile 50th position. 50th position we have to count from here. This corresponding value, as it is 80, this is 81. This position is 81. So lower quartile is 50th position. 50th position corresponding speed is 81. So our lower quartile is that means Q1 equals to 81. Here we have write 81. So 81 minus 81. So after subtraction, we'll get 13. 13 kilometer per hour is the interquartile range. At first, you have to find out the upper quartile, and we also find out the lower quartile. Upper quartile is 3n by 4. This is 150th position. From the cumulative graph, 150th position corresponding value will be upper quartile. This corresponding value, that means it starts over there. Here, uh, that means speed is 94, and upper lower quartile is 50th position is corresponding speed is 81. Both of the subtraction is interquartile range. So our interquartile range is 13. Okay. Now the number of cars with a speed greater than 110 kilometer per hour. So from here, if we count from 110, that means this is more than 110 kilometer per hour. That means 110 is here. This is 110. This is 110 kilometer per hour. So what they want? They want the number of cars with a speed greater than 110 kilometer. So greater than 110 kilometer. That means this is 2, 6, 8. Total 8 car is greater than equals to 110 kilometer per hour. So we have to write here 8 cars which are speed is greater than 110 kilometer per hour. Okay. So up to this question completed. Now P number. The frequency table shows information about the mass of each of 50 trucks. So here they give us the interval, mass, and the frequency. The frequency table shows information about the mass of each of 50 trucks. Here mass mkg, m greater than 2000, less than equals to 20 is 2600. The second one greater than 2600, less than equals to 3500. And here also given the frequency, we have to find out calculate an estimate for the mean mass of the trucks. We have to use the formula mean equals to summation xf divided by summation of f. So here we have to find out the mid value of this, mid value of this, mid value of this, and each of the mid value we have to multiply with this. So we will get 12 multiply the mid value of 2000 and 2600. We have to add both of these and divide by 2. We get 2300 plus like this 2600 plus 3500 divided by 2. It will be 3050 multiply 15 plus like same things 4250 multiply 16 plus 5350 multiply 7 divided by total frequency. Total frequency is 50. So if we multiply and add, we'll get here 17,008, 1,78,800. So or 178,800 divided by 50. So it will be 3,576. So result is 3,576 kg. So if you get this type of interval, you have to find out the mid value. Mid value multiply this frequency, mid value multiply this frequency, and after that, after multiplication, you divide it by total frequency. Total frequency means this addition, this, that. So all this frequency is altogether is 50. How we get the mid value? We have to add 2000 and 2600 divided by 2. In this way, we get the mid value. So Roman 1 completed. We already find the mean mass of the truck. Now we have to use this table for Roman 2 in a histogram showing this information. The height of the first truck is 6 centimeter. That means the height of the first truck. This is the height of the first block is 6 centimeter. If we draw the histogram, the first block, like here they said, the first block height is 6 centimeter. The frequency density here, this is 6 centimeter. First block is what? First block is 2000 to 2600. Like first block is 2000 to 2600. Here they said the height of the first block is 6 centimeter. Calculate the height of the remaining three blocks. So they want to ask us the remaining three block height we have to find out. Here they given us the frequency of remaining three blocks. So we have to find out the height or frequency density of the remaining three blocks. This is very important. Now see, for the first block, we know that frequency proportional to area, frequency equals to Ka. First block, we have to find out the area. Area means length multiply breadth. So length is, this height is length. This height is length, and breadth is the first block. Two interval subtraction is the breadth or width. So 2600 minus 2000, it is 600. So this is 3600 is area of first block. Now first block frequency. First block frequency is 12. This is the first block frequency. So first block frequency is 12 here. So we have to write that the frequency is 12 equals to K. Area of the first block is 3600. So from here we get K equals to 12 by 3600. That means 1 by 300. We have to remember when if K is not equals to 1, that's time frequency density means height. Formula is frequency divided by class width multiply 1 by K. Here frequency class width, K value is 1 by 300. That means we have to write here 1 by 300. So for other blocks, we have to use the formula frequency density equals to frequency multiply 300 divided by class width. To find out the height of the other remaining three blocks, we have to use this formula. Now, height of the block 2600 greater than 2600, less than equals to 3500. We have to use this formula. So we have to write here frequencies given. The second block frequency is here 15. So here frequency is 15 multiply 300 class width. Between these two subtraction, class width is 900. After calculation, you get 5 centimeter. 5 centimeter is the height of the second block. Like this, height of the block 3000 m greater than 3500, less than equals to 5000. Here frequency is 16. So frequency is 16 here. Multiply 300 divided by the class width is 1500. Both of this subtraction. So after calculation, we get here 3.2 centimeter, and the last one 5000 to 5700. Frequency is 7 here. Frequency is 7 multiply 300 divided by the class width is 700. So after calculation, we will get here 3. So 3 centimeter is the height of the last block. So I think everybody understand this maths. This is very interesting maths. At first, we have to draw the cumulative frequency. After that, by using the cumulative frequency, we have to find out the median. Median means n divided by 2 is 100th position. From here, 100th position corresponding value will be the median. After that, we find over their interquartile range. To find out the interquartile range, we have to find out the upper quartile and lower quartile. Upper quartile means 3n by 4. So 150th position, 115 corresponding speed is 94, and war quartile is n by 4, that means 50th position is corresponding speed is 81. Both of the subtraction is 13 kilometers uh, interquartile range. The number of curves with the speed greater than 110 kilometer per hour also we find here, and we find this type of continuous data mean if you want to find out, we have to multiply, find out the midpoint of this interval, multiply frequency, and add each of this frequency and divided by total frequency. So we have to find out the midpoint and this frequency plus this midpoint and that frequency, this midpoint and that frequency plus this midpoint and this frequency divided by total frequency. Here we get the mean value, and finally we find here the histogram. As they gave us the first block height, that is 6 centimeter, we need to find out the value of k. To find out the area of the first block, length into breadth. Length is the height here, and breadth is the difference between these two intervals. Here we find out the area. We know that frequency proportional to area, frequency given, area we find. After that, we get the value of k. If k is not equals to 1, here k equals to 1 by 300, we have to use this formula. Then this is the general formula for rest of the mass. Frequency density equals to frequency multiplied 300 divided by class width. By using this formula, we have to find out last tree block height. I think everybody understands this maths. Work hard, practice more. One last request for everybody: to stop global warming, please plant more trees. Thank you everybody for watching. Thank you all.